Well, hello. In this episode of Finogric Machining, we are going to, attach this rack, at the back of my bike. Well, the intention is to attach it in a way that either the bike nor this rack will be modified. Well, it doesn't fit there as it is. You will soon see. And for this reason I need to make adapter or actually several adapters to be able to attach it reliably at the back of this bike. So let's first figure out how we should do that. Well, okay. The rack is going to be over here. Yeah. And, well, let's see how that rack looks like. It is like this. And my intention is to put it around here somewhere, like that. That could be the correct place. I have here this water level, this level, because it's very difficult to estimate when it is level. Okay, there it is level. And my intention here is to get it in a place where it can be attached. You cannot see the places, they are here under. We have two on both sides. They are not meant to attaching this kind of a thing, but they can be used for that. Actually, there aren't any places where you could attach this one into there. Well, except on the axle, the shaft, but I don't want to attach it into that one. We have this fast lock, this rapid lock, this which you can operate without tools. So it will be somewhere here. Okay, yeah. Let's put that away. Then this end of this rack has a round thing here. Actually, it is mentioned for a 16mm bar, like this. This is aluminium, and if you have it there, it's quite stiff already. So my intention here is to have it somewhere there. It was around here when it was there. So this is one part of the adapter, this 16mm bar. Okay. Okay, and furthermore, when I look at the placing, I can see that, well, it's quite near. Let me show you. Here we have a place for a screw, and then we have an identical place for a screw on the other side. These can be used to attach this rack from this end, but naturally, as you could see, it cannot be done with that, so we have to make an adapter. So one part of this adapter is this bar that is like in this way, and then we need to have something that connects it to the sides of these mounting holes. The adapter that goes to down here is the bottom end that attaches to the body, the frame of this bicycle. That's not difficult, but this has very odd system here at the end. They seem to have a place for M5 bolt, which then should go into some at an angle like this at an angle to something. And well, the angle is like that actually, the correct angle. If you put it, there is a bolt hole here. If you put the bolt as it is intended, so then it is on an angle. Let's go to the lathe first and make start making these things that go here. And of course the bar that is sideways. I think I leave something extra here so you can bind your, if you want, you can have your octopus attached to it. So if you need, but yeah, okay. But that's our next thing is lathe. Okay, well, here we are at my lathe, and well, this is stock which has a very unbeautiful end. I will now beautify it first. Well, I will make two 40 millimeters long pieces out of this stock. Just measuring that we have enough room there for the thing. I believe this is enough. Yeah, leaving my key on the chuck is not very good idea. Okay, so I will first face this, and after that I will actually make a radius at this end. This will be apparent a little bit later why is it there, but it makes it a little bit well, it's about appearances, so to say. So well, let's see if I can find my tool for this radius making. Oh, here it is. There you are. I will be using that one. Yeah, so it's a very simple lathe job from now on. Now that we have done these pieces, the next step is to mill a flat here. This goes towards the frame of the bike. There is this M5 bolt which is actually going through this one. But we need a flat here. And this flat should be about 11 millimeters wide. So I'm going to make here a flat of 11 millimeters wide, and it should extend itself here to 25 millimeters. Furthermore, there has to be a groove for the cable. There is this back gear. We have the gears in the back of the bike, and the cable happens to go just here. So we need a groove here for that cable. Well, that's after the flat I will make that, and furthermore I will make a hole here, the 5 millimeter hole for the bolt. Well, then this side of this thing is ready. As you can see, it's supported here under. You might see a bit of it. This is adjustable parallel, which is supported from the downstairs, so it doesn't go down when I mill it now. Well, it doesn't. This is 2-flute high-speed steel end mill, which is really sharp, and this one, well, the cutting forces should be minimal. Well, you never know. But 11 millimeters flat. Let's do that now. Okay, so now back to my lathe. And this operation is now just to get rid of that nibble and drill a 5mm hole and thread it to M6. And this is a little bit slow. Now it's better. Okay. There you are. Nothing more than that. Center drill a little start hole in there so it doesn't wander around the drill when I start it. Doesn't need a lot. Like that. Just a dimple into there. Nothing more. Yeah, okay. And this is nothing very precise. Okay, my wrench like this, put it there. Back gear, because it otherwise would turn on me, and then we just go. This is aluminium and it's really soft. I can, well, this is going like into butter. We should do it all the way in because we need all the threads here. There it is. It's huh. Okay, let's move this away from here. Well, as you can see, the chips are coming out from the hole. They are not being packed into there. And there you are. That's it. Well, the lathe job for these two is now complete. So now I have temporarily attached these things on the frame, and well, there will be a bar here like this, going like that. It will be attached with two bolts, M6 bolts from the ends through this, and it will stay in place very reliably. And as you can see here in the back, the wire goes into the groove. It doesn't actually touch it at all. Well, maybe I need to deburr, get rid of all sharp corners so it doesn't eat through the cable sleeving. So, well, but there is a thing. These are not in right angle. As you can see, they, well, maybe you don't see, but I can show it to you with another tool. Actually, the tool I'm going to measure that angle later on here now. If I put this here, so you can see that it's not straight. These are on an angle. So we need to measure that angle in order to be able to duplicate that angle when I mill the flats for that bar here. So I have this is called a protractor, and I can use this one to measure that angle. Well, it doesn't need to be very accurate, but it shouldn't be too inaccurate either. Well, that's well enough. And then I can read from the scale here. Here is a scale. You might probably see it if it now happens. Well, 12 degrees, I would say. So, and that's included. So I need, each of these need to be 6 degrees tilted inwards. Okay. So now we know. That's the angle we need to replicate to the when we mill the flats. Oh well, sometimes these tools are needed. Yeah, okay, so and then we need to know the distance of those holes. Well, that's and that's also how would I say it? It's you can measure these in multiple ways. One way is to measure it like this, putting your calipers here and just measuring. With this method you can get down to maybe 0.5 millimeter accuracy. And I don't know whether this is accurate enough. Well, it should be, but let's see. In our case, if I put this here on the middle, well, it seems to be in the middle here. No. This is okay there. So it's 81 millimeters. Okay. Let's do. So by this method I get 81 millimeters. Then we have another way of measuring this. I will put this outside here because I know the diameter of these things. It's 16 millimeters. So this way I'm getting 98. 98 minus 16 is, well, 82 millimeters. And then, furthermore, we can measure the inside of here. Like this. And then we add, it's 61, and if we add 66, and if we add 16 to this, we get 82. So I would say it's not 81, it's actually 82 millimeters that we are after here, because 2 of the 3 measuring methods gave 82, and the one I measured directly under here, which is the most inaccurate way of doing this, gave me 81. So 82. And well, actually these are not flexible at all. So those holes should be quite accurately in place in order to get this working really. So let's start. So 6 degrees angle, the flat, and then the distance between holes is 82 millimeters. Let's write this down because I will forget it in a second if I don't write it down now. So 6 degrees and 82 millimeters. There you are. That's it. Now I don't forget that so easily. Okay. Well, yeah. Okay, now I'm going to mill the flats into this, this bar. That here is the center point, and these are the inner points of the flats. Well, there are different methods of doing this. First of all, I could tilt this workpiece 6 degrees, like that, and then mill that side. Then I could tilt it back the other way 60 degrees and then mill the other end. Well, there is a difficulty in that one. The flats must be like on the same level. They cannot be any tilted like this. And now, if I would move this workpiece while changing the ends, it would be quite difficult to make them on the same plane. So, therefore I decided not to move the workpiece, but to tilt the milling head. In this machine, tilting the head is really easy, and well, the 6 degrees tilt, yeah, okay. But there is a difficulty in that one. Well, when I tilt it, this end mill will move sideways. You will soon see what I mean when I tilt it, and therefore I cannot accurately tell when this edge is at the correct place here. So this is something I need to set up by sight. And therefore I have these marked the places where it should go approximately. And and this is, well, not that, it doesn't need to be that accurate, really. Then we have a thing that, and then this end mill. The nominal diameter is 20 millimeters, but since this is a regrind and I measure it from the ends of the flutes, it is actually 18 millimeters, which is really good. It gives me 1 millimeter extra here, and that's actually very good. Okay, I'll take that. So now we need to move this. First of all, tilt this. And this is now a very easy thing to do. I just loosen my head, here is a brake, and then I tilt it this way 6 degrees. Not that way, but this way. And there is your, quite accurately, your 6 degrees there. So now you see how much it moved. Actually, it moved away from here to there. And yeah, okay. So now I move this here. And I tilted it the wrong way around. It should be tilted the other way. Oh man. So let's tilt it 6 degrees this way. There you are. Now it's 6 degrees that way. And then we can. This has a sharp edge, which I now can align with the line here. Well, it was quite exactly on place. Yeah, I think it's there. Let's see. Well, a little bit more this way. It's better to have it... Okay, there you are. And now I just mill deep enough here so that there is a flat also on the end of this. So it will be quite deep. And when I'm finished with this one, I will... there is a dial for Z, the vertical direction. I can then lock my dial there, zero it there, so I know how deep to cut the other end to get them identical. So here we go. Okay, now we have two flats which are in 12 degrees included angle, 60 degrees each, and these should match exactly with the pieces already in the bike. So now I will straighten this up because now the next step will be to mark the places for the holes. I cannot drill those with this constellation because, because I cannot. So, and this milling head has a nice indexing mechanism where you can put it really straight. There it is. So now it's straight, and what we need to do is to change that. For something that we can use to mark the places here. Well, since those surfaces are tilted, if I want to mark reliably the places, I need something like an end mill. And in this case I'm using a round-nosed end mill. This is probably 3 millimeters, maybe more. It's maybe no. Well, I could read it. It's a small end-nosed end mill. So I can use this one for marking the holes, the places for the holes. That's not okay, that's not okay, so there is our middle. So I need to put some color into that one. Like that. So I estimated it would make 18 millimeter wide thing here. Let's see if it is 18 millimeters. It should be quite near that. Well, it is 18 millimeters, so 9 millimeters from the sides. So that one 9, and this one 9, and there you are. It's in the middle there. The lines are a little bit apart, but I will point this thing in the middle of the line. So let's go there. Because I need to measure the 82 millimeters. I have to reset my dials here, so I can move it 82 millimeters when the time comes. So now, what I do, I will just... Oh, it's a slinging oil. That's... Okay, now, let's make a dot in there. There. There is the place for our first hole. You might see it or might not. So now I just move 82 millimeters. Well, yeah. And now we just make another point here. There you are. Well, that's it. Now we have marked the places for the holes. The next step is to get this. Well, I will debure it now, and then we drill the holes. These holes will be 6.5 millimeters. The bolt is M6, so in theory you could put it into a 6 millimeter hole. But I want to have some slop in there, some play in there, so it will be 6.5 millimeters. That way we can, if I made some mistakes here, so I can, it should accommodate those mistakes. Yeah. Well, as usual, I fucked it up. So, what happened here is that the flats are the wrong way around. They should be tilted like this, not like that. Well, this is, yeah, luckily we have quite a lot of material there still, so we can make it tilted the other way around on both sides. And we are still a little bit above the center line, so it means that we have the maximum strength in there. So nothing to worry about. Well, yeah, I should pay more attention to this. Man. Okay, now what we shall do next is to drill the 6.5 millimeter hole, the holes, one here and one at the other end. And I aligned this flat. It was quite easy, just so that it's level with the top of the vise. So nothing more special than that. And now I will by sight place that drill over that marking we have there. This shouldn't be too hard to do. Just place it there, first this way around. Oh, I need to lock my table, this moves so easily. Well, there. And then this way, well, I think it's already in place. So, now just drill the hole. Well, let's go. Easy enough. Okay, now. Well, now we need the recess for the cap screw to the other side, and we have to align this so that this hole, well, I will use the drill for this one. So I put the drill inside there, like that, and then I just go down. Then the angle goes the right way. I'm just checking that. Oh yeah, okay. I think there we are. And then we just make the flat here. 10 millimeters should be enough. I know that I have had some bolts that are not. Oh well, let's see. That should be it. Now we should have recesses for the M6 bolts in this one. Wow, it looks great. They could be a little bit longer actually. But let's try with this. Okay, well, it was successful. It's here, it's quite stiff. Well, of course you can bend it slightly like this, because it's pivoting with these M5 screws, but that will also, there will be another support here, but let's go to that a little bit later. So first of all, this is the rack now, and it will go back here. There is this round thing. The radius of that is 16 millimeters, and now this is the diameter of that one is also 16 millimeters. So now I need to figure out when it's like horizontal. So I use again this. I need to figure out when it's level. Okay, there. So it's about 10 millimeters. Well, the bottom of this is about 10 millimeters above that thing here in the back. Okay, then it's level. I need to figure out when this, if this is now the 1 centimeter above, if this is pointing directly to that hole. And it is actually. That's not actually round, but I think I can, it's safe to say it's quite near 16 millimeters. Well, it's not, it's it varies. Okay, so if I put there a round thing, maybe 25 millimeters in diameter, so I should be able to have the continuation going then straight through that one. Well, yeah, okay. And actually I can make those such that they are spreading or making it narrower. Yeah, okay. Or even if there are angles needed, so I can make them such. And they are round here, they look nice. Okay, let's start with those. This here is a round-nosed end mill. Well, it's a high-speed steel and it's only 2 flutes. It would be well suited for aluminium, but this is mild steel. And this might be a problem, as a matter in fact. And I have now attached this to the vise, and as you can see, it's not... it's supported on the sideways only by friction. So this is as tight as I dare to turn this, and it's well, I'm afraid that it will actually move into this one. But well, we shall see. It shouldn't if I'm really careful when I do this. Something like 0.2 millimeter cuts. When I'm deep enough, first I can do a little bit more because but when it comes wider, I need to be really careful with feeding. It might do something nasty. Yeah. So, well, safety glasses in this case are really a must. And I have centered it by side. Actually, I need just a radius there to accommodate the rack ends, which are also round. The radius of those is variable, so this is right in the between of their radius. So hopefully I get it in the vicinity of the correct radius, right in between of those. So, well, let's start doing this radius there. this groove is probably now, not probably, I know, it's wide enough for that rack end. And well, now I just need to do another identical. Yeah. Here I'm drilling a 4mm hole. Well, here to be used to attach the rack to this workpiece. Well, there will be a M5 thread. Well, the correct drill size for M5 thread would be 4.2mm, I guess. But this is 4mm, and since the well, the minor diameter of that for M5 thread is 4.1 something, this should do. But yeah, it will be a little bit tight to thread, but this is mild steel on the other hand. It shouldn't be too hard. But if I snap my tap into there, then you can say, what did I say? Just please put that into comments if I snap it. Well, there is a danger because it might not cut well. So I have aligned this so that it this is totally aligned like by side. There is nothing precision here. So I'm just I first set up the drill in a way that I could see that it so that it avoids this hole, which will be tapped to M6. So it has about enough clearance for that one. And then I aligned this workpiece rotationally in a way that it goes in the middle of that, round part. Well, and now, of course, and then I have aligned this in a way that I have used this to align this workpiece to this side of the vise, so that when I do the next piece, which is already sitting here, I can put it in place quite easily. Furthermore, this workpiece is here to balance the moving jaw in a way that it doesn't bind when I tightened this. So now, well, we should be able to drill that hole. Let's see. Well, I'm using a little bit too little speed at the moment. It should be around 500. So let's speed it up. There you are. And well, then I just drill this. I'm not going to drill this all the way through, and there is two reasons for that. The first reason is optical, so it leaves the underside intact. And then the other one is more like machining related. When you tap a hole, especially because now the thread is quite tight, when it comes, if it would be a through hole, and I would tap it all the way through, the tilted surface here in the back would cause sideways load to the tap, and that very easily snaps the tap into the hole. Very easily. I have done that. So therefore it's a blind hole. So now I just locate the other piece. Now I feel here in the top that it's about where it was. Well, now that I know, I can take this out. Let's see. Well, maybe you can see how deep the hole is. It's all the way, I believe, up to here, actually. So it's certainly it's deep enough. So now let's take these chips away from here, and then we have this comes here, and that goes there. And now let's first tighten this a little bit, just a little bit, and then I try to rotate it so that it's about in the same location. Yeah, now it's about in the same location. I can also look with this that it's, yeah, it looks like. Then I just tighten it there. And then we do the other hole. Yep. So now this thing succeeded better than I expected. First of all, it seems like the bottoms of these are level this way, so they don't continue to spread. And now if I look at here, when this side is level, so is this. Well, I was really lucky with this one. So now if I raise this to the point, it was 1 centimeter above here, so that we have a 1 centimeter gap here. So we need something in between this point and that point there. And well, if I now take my ruler here this way and measure this distance, it will be like in the center here, and I will well use this material for it, and I will actually split it in half on both ends, one for this end and the other for that bottom end. And then the top end will have a 6mm hole for a M6 bolt, and the bottom end will also have a 6mm hole for M6 bolt. Yeah, I have measured or tried that that hole here, at this point there is a drop-shaped hole. Oh man, that can accommodate M6 bolt really easily. So now if I measure this distance here somehow, let's see now. Okay, that's that one and about here. So we are going to need 120 millimeters. I can always shorten those really easily. It's really easy to shorten those, but they must be originally long enough. Can I measure it so that I get some? Because here at the bottom we don't have a lot of room to spare. There is this weld which is actually on the way, and it cannot go past that one. Then the surface becomes, well, uneven. Unless I put a washer there under, which is about 5mm thick. Then I can go past that one. But then again, it will jeopardize the rigidity of that one. So not a good idea. So, okay, now here I can measure it. It's 10mm there, over, and here, well, 120 from hole to hole. Was it? That hole to that hole. 110 from hole to hole. And then we must add something at the top and something at the bottom. So 130 is probably the way to go, because here it can be like quite ways past that. So we have at least 10mm play here, but there we don't. 100. Let's measure it one more time. So I really don't make it too short. That would be really bad. Well, there you are. It's about there. It's 110, the distance between the holes. And then here we need to add, well, 7, no, maybe 7mm. No, let's add 10 for that end, and well, 15 for this end. So it would be 110 plus 25. It's 135. So 135mm long thing, which I then adjust to suit this thing. Well, that's it. So, and this is the material, and this will be, I will cut it off in the lathe. Maybe, yes, I will do a radius at both ends, and then in the milling machine I will split this in half on both ends, and that's it. Yeah, okay. this is now almost ready. So what we need to do here is to mill half of this away, like flat, and also same for this side, and this will be like 25 millimeters long at this side and 35 millimeters in that side. That will be the upstairs side and this will be the downstairs side. Furthermore, there will be holes drilled into the one hole, 6 millimeter hole here, 10 millimeters away from that edge, and then 15 millimeters from that end here. So that should give us the proper 110 millimeter distance between the holes. Well, I guess we just start milling here. This side I have already here, and then we have your side, so to say. And this is a pretty simple thing. What I needed to cut off with file something from this corner because of the weld down in there. It was not possible to put it from that side, so I need to change the side to this side, like this. Okay, that's it. And then we have a screw and a washer and a nut. And the screw comes from this side into the hole. Please. Okay, so there. And now it sits flat on the back side because the weld is no more like lifting it up. Okay. Oh, man. Okay. These are just M6 hardware, normal hardware, to keep it from rotating at the back side. Actually, I can tighten it from the back side. Okay. Well, the capacity of this rack is maximum 25 kilograms. Well, this means that well, each of these at the maximum load, these would receive 1/4 of that, like static load. Okay, it's already really rigid. and the top is not even tightened yet. And the same here, I can actually tighten this one as well. Let's see if I actually don't want to tighten this fully at the moment. There is a reason for that one. Let's see now. This side as well. Oh yeah, this was totally loose. So, the main idea of this all was to avoid all sorts of modifications to the bike frame and to the rack. So, like, just make a adapter. And that's exactly what we have now made. This is all this hardware here, it's rack adapter. And yeah, here we have the somewhere here we have the, where are those? Oh yeah, there. We have the screws that, the cap screws that tighten this into that. Okay, now, well, we still have one place where we need to drill a hole and thread it, and it's here. And well, this is really steady. Well, you cannot pick it easily up. Huh. It would hold itself even if okay, I need to let's see. Now we need to drill a hole, but it's in an angle, which I don't know what is the angle. This is actually a center punch. Let's see if this is 6 millimeters. No, it's not. It's over. Next. This should be. Okay. I just scribe with this one. There should be now a scratch there. I will very soon see if we have a scratch in there. Yes, we have a scratch. Now I will drill a 5 millimeter hole, tap it to M6, and then we are ready with this one. Yeah. Well, it's here. It's very, very stable, stiff. It doesn't bend anywhere, and it doesn't rattle. It's perfect. And this is now achieved without drilling a single hole into the frame of the bike or modifying the rack in any way. So all what I have done is just an adapter. And there are some points here which has to be, well, it's not beautiful for the first, yeah, it's not. But it's very practical. And well, of course we have aluminium here, and then we have steel. And this is a mild steel. it means that something is going to corrode here. And it will be actually the mild steel that will corrode. But on the other hand, the aluminium is something like zinc. So if you think about the electric series, so it will actually inhibit a little bit of corrosion on that one, but I doubt it will inhibit, it will rust. Well, I will have a rust inhibitor them, but first I let them rust a little bit. And this is the reason for this is that then that rust inhibitor grips better on this material when now it's too slick, so to say. Okay, and well, the bolts here, the cap screws are all stainless, so well, they might actually react with when they are in contact with aluminium. That's always something. Okay, so and then why did I need a rack here? Well, the reason is this. I have a bag like this which goes here. It goes into that place, like that. And now I'm ready to go to shop. And goes to pick up like that. There is a thing here which I need to adjust to suit this rack perfectly so that it will not flap in the wind. Well, me cycling wind? No. It will be, at first the pace will be really slow, but it will get better when I get some training. I know because I have been doing this earlier as well, so it takes some time, maybe 2 months, and after that it's really like, well, hopefully. So now we have it done. Well, what will it be in the next episode of Finno-Ugric Machining? Well, it will be the input manifold for the rotary vane compressor. Well, yeah. And yeah, okay. Furthermore, I would now like to thank my son for donating me this rack. This is actually very good quality rack. This is the brand is Rack Time, and this is a German-made thing. It's really made in Germany. It's not Chinese. It's a German. And then also these bags he donated me. These are very practical when you go shopping. And of course, for the balance, I have the other side if I really need, if there is a lot of beer, for example, to get from the shop. So yeah. And I don't know whether I already talked about the load, how much load does this tolerate. The rack itself tolerates 25 kilograms. And I believe that my shop, what I need from, and my wife needs from shop, it never ever exceeds like 10 kilograms. So that should be totally suitable for this one. Yeah, so wish me luck with this one. Yeah, careful in the traffic. Yeah, so till next episode, bye!